If we wanted to find the equation for the line of best fit, given this information right here, where is it that we're going to go? And we get there by clicking on Apps, Data Matrix Editor. Again, if you have to do, if you're using the one online, you may have to do New. Just give it a name. It can be anything gibberish. It can't be X and it can't be Y. It can't be a single. Shouldn't use a single letter because that's often assigned some value to your calculator. So make sure it's just some string of letters that don't make any sense or that don't have anything to do with a calculation that the calculator might perform. And then you can open that. Okay, and then you just start entering your X and Y. So if we enter our X coordinates, 0, 2, 4, 5, and 6, and then we enter the corresponding Y's. So I'm just going to go up the column. All right, so I've entered all my information. Okay. Can you predict right now whether this is going to have a positive or negative correlation? If you think about the sketch of this, okay, 0, 1, and then 2, 3, 4, 6, 5, 6, 6, 8. So here's your anticipation is the line goes up and to the right, so it should be a positive correlation, right? The correlation compares to the slope. It's a positive slope, so positive correlation. Eileen and Maddie, last chance, okay? Or I'm going to split you guys up. It's too often that you guys are paying attention to each other and not to me, okay? Eileen, you got it. All right, so you have this positive correlation. Okay? So we should anticipate our slope to be positive when we find the equation of our line. So when we go through this, the next step to identifying our line of best fit is to use what? F5, the Calculate tab. Okay? And we want to change our calculation type to linear regression, assign our values for X and Y. Okay? Again, pay attention to your letters. It starts off with an alpha lock, right, but then after that you need to change it. And then the store regression equation. Again, you can put it anywhere that you want. Y1 of X is just the easiest one. It'll put it in that first spot. However, if you're doing multiple problems with the same spreadsheet, you might want, and you want to keep track of your old equations, you can change to Y2, Y3, and so on. Change the store regression equation to Y1 of X. And when you do that, you get your equation. And now I want to talk just a second about what these other values mean. Because when you look at this, you get your new equation for this line of best fit, which is Y equals 1.14x plus a y-intercept of 0.93. If we're rounding to 2 decimals for this. Now, if you wanted to check to see whether or not this is a good line of best fit, whether it actually works, and the CORR means the correlation coefficient. The closer it is to 1, the more likely, or this line represents that data. So is this value 0.987 pretty close to 1? Yeah. So that means that you have a good fit. This is a good line of best fit. And I want to compare that to something that happens if we change a few of these values. And so are there questions on what we did right here? Okay, so that's all you need to do for each of these. Again, the time-intensive part would be to enter your data, but once you get comfortable doing that, you should be able to do it relatively quickly. Let's go back to our data. Eileen, question?
On the notes, can you explain the first part of correlation?
As far as the positive, negative, or no? Positive correlation means you have a positive slope. Negative correlation means the slope's negative, and no correlation means you can't even fit a line. There's no consistent line in that.
Oh,
All right, again, this correlation right here is just telling you how good of a fit this line is. The closer it is to 1, the better fit it is. And let's see what would happen if we took all of this data here and we changed these y values to negative. Okay, so if you go back to your information here and you just enter the negatives, the opposites of each of these pieces of information. And then perform the same thing. Now the nice thing is we haven't gone anywhere, so all of our settings should be saved. So it should already be linear regression with the C1, C2s, and it can still store it too. And this time I'm going to change this and store it to Y2, so I can see a second equation. The second equation is if all of these values were the negatives. And so when we look at this, we get y is equal to negative 1.14x minus 0.93. Is it surprising that these would be the same? Almost identical numbers, just the different opposite slope and the opposite y-intercept. Think about what adding these negatives would put our points down here, right? So should our line of best fit be basically just the opposite of what it was above? Yeah, that makes sense. What do you notice about the CORR here? Now it's close to what value? The correlation coefficient, again, the closer it is to 1. Okay, this says negative 1, right? That tells you, and this kind of brings up Eileen's question, that tells you what kind of correlation are you looking at for this blue line. It's close to 1, so you know it's a true line of best fit, but it's a negative in front, so that tells you the correlation is negative correlation. And now, I'm guessing most of you can see that tendency without having to rely on the message that your calculator shows you. Okay, but I just wanted to let you know a little bit about what that is. The R squared value is something in statistics that indicates what part is determined by the variation, what part of the y variation is determined by the variation of x. You don't really need to know that. Again, it's the closer it is to 1, the more accurate your line of best fit is. But the CORR value is going to tell you whether it's a positive or negative correlation. Okay, so let's try one last case. In this last case, let's change the sign back for several of these. So for x equals 5, let's change that to a positive 6. And for x equals 2, let's change that to a positive 3. And let's see what the equation gives us. So if we're plotting this point, we're looking at negative 1. I'll plot these as larger points. We're looking at 2, 3, this point up here. We're looking at 4, negative 6, 5, 6, and then 6, negative 8. So what would you guess looking just at these 5 points? Is there any correlation here in a linear relationship? No. Now, when you guys get to trig, and there is a possibility that this could fit a trig pattern where it waves, okay? But we're not talking about or we're not covering anything like that. We're just looking to see does it fit this linear equation form. So let's calculate that again. It's all set up for you. This time I'm going to write the equation in y3. And so it gives you an answer, right? So it will tell you, if this is a linear equation, it will tell you what the line of best fit would be. But what do you notice about this correlation? Is it anywhere close to 1? No. And the fact that it's a negative 0.27, it means that this is a bad fit. And when you look at the R squared value, again, the closer it is to 1, the more accurate the line is. Is 0.07 anywhere close to 1? No. So this would be the case where you would have no correlation. Right? It's not close enough to 1.